Hi everyone, this is Professor H. Rahman from Agricultural and Food Engineering Department. I welcome you all to this NPTEL online certification course on trucks and engineering. This is lecture 38 where I will try to cover the steering of wheeled vehicles and steady state handling of front wheel steered vehicle. The concepts which will be covered is steering geometry and the steady state handling of front wheel steered vehicles. Now, when I say handling characteristics, so handling characteristics of a road vehicle refer to its response to steering commands and to environmental inputs. Inputs could be wind gust, it could be road disturbances which will affect the direction of motion. So, there are two basic issues which are associated with vehicle handling. The first one is the control of the direction of motion of the vehicle. The second one is the ability to stabilize direction of motion against external disturbances. So, first I will see the vehicle as a rigid body. It has 6 degrees of freedom, translation along x, y and z axis and the rotations about these axes. So, which are clearly indicated in this figure. There will be a translation about x axis, this one is the x axis and y axis lateral velocity and z axis is your vertical velocity, and the rotations are called roll velocity, yaw velocity and pitch velocity. With respect to x axis it is roll velocity, with respect to y axis it is pitch velocity, with respect to z axis it is yaw velocity. So, this is the vehicle axis system on which I have indicated these forces and the moments which are acting. Then during turning what happens, the vehicle body rolls and this roll motion may cause the wheels to steer, thereby it will affect the handling behavior of the vehicle. So, before we move into the steering, let us first see what is the steering geometry of a vehicle. So, I have indicated this is a 4-wheel vehicle, that means the front wheel are steered, and if I draw perpendicular to all these wheels, they will meet at a point O, that is the center of rotation, and I have connected O with CG of the vehicle. So, that is indicated as R, which is nothing but your turning radius, and the wheel base is indicated by small b and the track width is indicated by small t, and delta I, that is the steer angle of the inside front wheel. We are taking a turn to the right, so that is why delta I is the steer angle of the inside front wheel, which is also called major steer angle. Similar to delta I, there will be an angle delta 0, which is called steer angle of the outside front wheel, and it is called minor steer angle. Now, if you look at the right angle triangle OFC, then delta I will cot delta I will be equal to x upon b. Similarly, if you look at the right angle triangle OED, then cot delta 0 will be equal to t plus x by b. So, now if I take the difference between cot delta I and cot delta 0, so that becomes t upon b. This is the perfect steering conditions where all the 4 wheels are rolling, and this is what is required, but in practice we never achieve this. Next, we will see what is the steady state handling performance. When I said steady state handling performance, this is concerned with the directional behavior of a vehicle during a turn under non-time varying conditions. For example, a steady state turn is a vehicle negotiating a curve with a constant radius and at constant forward speed. We are not changing the forward speed, we are not changing the constant radius. So, that is called steady state handling. When the vehicle is negotiating a turn at moderate to higher speed, the effect of centrifugal force which is acting at the CG of the vehicle can no longer be neglected. So, what will happen? To balance this centrifugal force, the tire must develop appropriate cornering force. These cornering forces are developed at the contact patch of the front wheels as well as the rear wheels. So, because of this, a side force will be acting on the tire and the tire will produce a slip angle. So, let us now see this. I have taken I have represented this figure assuming that both the wheels are developing the same cornering force, and I have indicated only one wheel, one on the front, the other one on the rear, and both the wheels, that is the minor steer angle and the major steer angle, are assumed to be same. So, these are some of the assumptions I made which has been made to simplify, so that you can derive the fundamental equations related to steering or handling characteristics. So, the first assumption is a vehicle is negotiating a turn at a constant speed, and the forces which are acting on the vehicle will be obviously the centrifugal force and the forces acting through the tires. And here the major steer angle of the inside front wheel and the minor steer angle of the outside front wheel, they are almost the same, and so the forces on each of the front and each of the rear wheels are the same. So, then the forces shown acting on these tires are simply twice the forces which are acting on each of the wheels. So, here I have indicated the centrifugal force, which is equal to W V square by G R, and the vehicle is taking a turn. The steering angle I have indicated as delta F, and the forces which are acting will be the side force FSF, which is on the front wheel, and the side force FSR, which will be on the rear wheel. And the slip angles corresponding to the front wheel is alpha F, this angle, and the slip angle at the rear wheel will be alpha R. And the steer angle, that is delta F, the angle by which the vehicle is turned, is delta F. Now, if you look at this diagram, I have indicated the wheelbase as L, and the distance of CG from the front center of the wheel, that will be equal to L1, and the rear center of the wheel from the CG, that distance is L2. Now, the angle which is sustained, that means if you draw two lines, perpendicular lines to these two wheels, they will meet at a point O, and the distance from O to CG is denoted as R, which is the turning radius. And the angle OA, this triangle OBA, this is a right angle triangle, and the angle subtended at center, that is AOB, will be equal to alpha R plus beta. Similarly, the angle on the other right angle triangle, that is OBC, so angle BOC will be equal to delta F minus alpha F, that means delta F is the steer angle, alpha is the slip angle, and beta is the angle by which the vehicle has turned. So, summation of this will give you the total angle tau. So, now the slip angle of the front and the rear wheels, as I was told in the beginning, that this will be equal to alpha F and alpha R. So, when a vehicle is negotiating a turn at the moderate or higher speed, the four tires will develop appropriate slip angles. To simplify the analysis, the pair of tires on an axle are represented by a single tire with double the cornering stiffness. And beta, I said, is the angle between the direction of motion and the vehicle CG. Motion of the vehicle CG is the direction of is the angle between the direction of motion of the vehicle CG and the vehicle center line. And delta F is the steer angle of the front wheels, and O is the instantaneous center of turn. So, I have indicated those forces. Now, I said tau will be equal to, for small angles you can take assume to be a arc of the circle, so that becomes equal to L upon R. L is the wheelbase and R is the turning radius. Now, this will be equal to alpha R plus beta plus delta F alpha F minus beta. So, minus beta plus beta, they will cancel out. So, ultimately what we are getting is delta f is equal to L by r minus alpha r plus alpha f. Okay. Now, we will try to find out what are the forces and moments which are acting by resolving the forces which are acting on the wheel into two components. One is parallel to the radial line, the other one is perpendicular to the radial line. Okay. So, and then taking the algebraic sum of forces and moments, we will try to develop the fundamental equations. Okay. Let us now see what are the forces which are acting parallel to the radial line. So, the first thing will be W v square by g r is the centrifugal force. Then this will be, if you look at the front wheel, then it will have a component A O f sin delta f minus beta. Okay. So, this will be equal to f s f cos delta minus beta, delta f minus beta, okay, plus then we will go to rear wheel. So, f o r sin beta plus f s r cos beta. So, f s r is the side force which is acting at the rear wheel, and f o r is the basically the rolling resistance of the rear wheel, and f s f is the side force which is acting on the front wheel, and f o f is the rolling resistance of the front wheel. So, this will be the summation of forces, or the forces acting parallel to the radial turning radius. Similarly, we have to find out what are the forces acting perpendicular to the turning radius. So, resulting the forces perpendicular to the turning radius, what we get is f s r sin beta is equal to f o r cos beta plus f o f sin delta f minus beta plus f s f sin delta r minus beta, delta f minus beta. Now, taking moments about the C g and then equating it to 0 as there is no external moment applied at the C g. So, what we get is L 1 cos beta into f o f sin delta f minus beta minus f s f cos delta f minus beta, okay, plus L 1 sin beta into f o f cos delta f minus beta plus f s f sin delta f minus beta plus L 2 into f s r. So, these are the three equations which we got from by resolving the forces parallel to the turning radius, perpendicular to the turning radius, and then taking moments about the C g. And then, so what happens exactly is this delta f and beta, they are not very high angles, they are very small angles. So, you can approximate is closer to 0. So, that means these sine components will be more or less 0 and the cos components will be 1. So, now the equation 1 will be resolved as, so this can be written as W v square by g r will be equal to f s f plus FSR. Okay, this will be equation number 3, and the equation number 2 will be equal to, the sign component will be 0. Okay. So, that means FOR plus FOF, this will be equal to 0, and from this moment what you get is L1 into FSF will be equal to L2 into FSR. So, these are the equations which we got from here when we assume that the alpha, assume means this delta f and beta, they are small, that is why you have resolved this 1, 2, 3 equations into 3, 4 and 5. Okay. Now, from this equation number 5, we can say that FSF will be equal to L2 by L1 into FSR. Now, if I substitute this value in equation number 3, so then it will becomes FSF, sorry, L2 by L1 FSR plus FSR will be equal to W square by GR. Now, if I take FSR common, then it becomes W square by GR into L2 by L1 plus 1, that means L1 by L1 plus L2. Now, from equation 5, what we got is FSF will be equal to L2 by L1 FSR, or FSR will be equal to, either way, FSR will be equal to L1 by L2 into FSF. So, if I substitute in the equation number 3, so W V square by GR will be equal to FSF plus FSR, if I write as L1 plus by L2 into FSF. So, if I take FSF common, so 1 plus L1 by L2, sorry, L2 plus L1 by L2. L2 plus L1 is nothing but FSF L by L2. So, FSF will be equal to W into L2 by L into GR, this is equal to FSF. So, this W V square, sorry. So, now this W into L2 by L1 is nothing but what is the weight acting on the front axle, because we have taken Fs is the total weight which are acting on the both the wheels. So, I can write as Fs will be SF will be equal to W F B square by GR, where WF by 2, because I assume that WF is the weight acting on the each of the front wheels. Okay. Now, similarly, I will find out FSR will be equal to WR into V square by GR, to GR. So, now if I substitute this one in this equation, this equation, so before that we have to find out what is the relationship between the FSR and FSF with the slip angle. Usually FSF is related to the slip angle, FSF is related to the slip angle. That means the cornering stiffness into slip angle. Similarly, FSR is the cornering stiffness of the rear wheel into alpha r. So, I can substitute here for FSF. So, FSF cornering stiffness in the front wheel, if I write as alpha f into alpha C alpha f into alpha f will be equal to WF B square by 2 GR, or from here alpha f will be equal to WF B square by C alpha F into G R to G R. Okay. So, Fs F, I have found out expression for alpha F. Similarly, I will find out expression for alpha R, which is nothing but Wf B square by 2 C R C S R into G R. Now, if I substitute this value in this equation, so finally what we get is delta F will be equal to L by R minus alpha R, which is nothing but Wf by B square by G R and alpha B this is W R, this is Wf B square by G R. So, now if I take common B square by G R, now C S R C S F. Now, if I take L by R minus B square by G R, if I take common, then what I get is W R by C S R minus W F by C S F. Okay. Since this W R by C S R and W F by C S F, this is nothing but is called as understeer coefficient. So, delta F, that is the steering angle, is a function of wheelbase L, it is a function of the turning radius R, it is a function of the speed at which is taking a turn, it is a function of the weight distribution, it is a function of the cornering stiffness of rear and front tire. So, this is the fundamental equation governing the steady state handling behavior of a vehicle. Now, I will show you another handling behavior, which is nothing but how the tractor is behaving, or what is the stability of tractor when during while moving on a side slope. So, we will discuss about side slope stability now. So, the vehicle is moving across a slope, the slope of the surface is beta from the horizontal, and the wheel has a track width T, and the CG height is h from the ground level. Okay. Now, tan beta will be how much? T by 2h. Okay. When the tan beta is greater than T by 2h, T is the track width, h is the height of the CG from the ground, then the vehicle is going to overturn. So, if beta will be equal to tan inverse, tan beta is greater than T by 2h, then the vehicle is going to overturn. Now, the other thing which you are going to verify is whether the tractor will slide down. Why it will slide down? Because the forces which are developed at the contact patch, both at the rear wheels as well as the front wheels, they should oppose the weight component which is acting here, W sin beta. So, that is why I have written W sin beta will be greater than FSA plus FSR. Then what will happen? The tractor will become unstable and it will slide down the slope. So, these are the two conditions which are to be verified when the tractor is moving across a slope. Okay. So, when I said FSF means the total side force acting, when I said FSR means is the total side force acting on the rear wheels. FSF is the total side force which is acting at the front wheels. That means, you have to take side force of the front wheel, both the wheels, and side force of both the rear wheels. So, now I will try to summarize what exactly we discussed in this class. We discuss the fundamental equation which is which governing the steady state handling behavior of the vehicle, and where we found out that the steer angle which is required to negotiate a given curve, how it is dependent on wheel base, how it is dependent on turning radius, forward speed and understeer coefficient of the vehicle. And in fact, it also depends on the weight distribution. Understeer coefficient is nothing but weight divided by the cornering stiffness. So, that is why, in other words, we can say it also depends on the weight distribution on the front and the rear wheels, and the steering stiffness of the front and rear tires. Then we also discuss the handling characteristics of the vehicle, how it is dependent to a greater extent on the relationship between slip angles of the front and rear tires. Then we also discuss the side slope stability of the tractor, and what we observe that is the side slope stability, we have to check two conditions. The first condition is the overturning, and that is dependent on the track width and the height of the CG, and the second one is the sliding down of the tractor, which is dependent on the side force. That means the side force which are developed, or the lateral force which are developed at the front and the rear tires, that should be sufficient to support the sign component of the weight of the vehicle. So, you can refer to Wong's book Theory of Ground Vehicles to further improve your knowledge on this. Thank you.